Good morning, dear students. My name is Ferhan Mazher, and today is 5th of January 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O-Levels Physics. Today, we have decided to do a theory paper. We call it paper 2, and we have selected October-November 2017 paper. Today, we will solve its section A. The section A is from question number 1 to question number 8. The section B of this paper, we will solve in another session, in another video. So let's start today's paper. And okay, so October-November 2017, 2-2 paper. This paper belongs from the Zone 2, Variant 2. And today we are going to solve its section A only in this session. Two small tugboats are pulling a large ship in a harbor. Figure 1.1 represents the view from above and shows the directions of the forces on the ship. So here we have a large ship, here two tugboats, and they are connected with this large ship and they are pulling it. And the ship is going in a straight line towards the right side, and they both are pulling in, making 20-degree angle with this straight line in which the ship is going. This tug ship is also making 20-degree angle. The force applied here is 49 kilonewton. 49 kilonewton. Each of the tugboats is exerting a force of 49 kilonewton on the ships. Determine by a graphical method the resultant of these two forces and state the scale used. Okay, so we have to find the resultant of these two forces, and we have to use the graphical method. And so it's the addition of two vectors because the forces are vectors. So we will use the graphical method and we will add these two forces. And I will use the parallelogram law method. And this 3-mark question, you have to mention the scale and you also have to tell the resultant. Okay, so these are the two forces. So what I will do, I will on a white paper, on this paper, if you have a hard copy here, you put a dot here, and then you draw a line towards the right, a horizontal line, and you put a protector here and you measure 20-degree above that, 20-degree below that, and then I will, according to the scale, draw these lines. Let me show you my work. So, okay, so here we go. So what I have done, on the paper, I have put a dot here. So that will be representing the point where the main ship is tugged. And so that's the horizontal line. And you can see the 20-degree here. I put a dot on the paper. And this is that dot. Now I have changed the direction, orientation of the protector. And I will go 20-degree below this line. Okay, so I put a dot here. So I will draw lines here. And so I will use a scale in which 1 centimeter will represent 10 kilonewton. Okay, so the scale I'm using is 1 centimeter. A centimeter will represent 10 kilonewton. And you can see here, I have joined this point with this in this direction. This angle is 20-degree. I have drawn a line of 4.9 centimeter. In the same way, I have drawn a line here, which is of 4.9 centimeters. So because I have to draw here a force of 49 kilonewton. So 1 centimeter represents 10 kilonewton. So 49 kilonewton will be represented with 4.9 centimeter. Then, and I can put arrows here because this force is in this direction. You can put an arrow here because this force is in this direction. And I will use the parallelogram law to find the resultant of these two forces. And you know, in the parallelogram law, the two vectors to be added, you put them in such a way that their tails are joined. So let me draw the arrowhead. So it will become, okay, so let's take a pen. Okay, so put a arrowhead here. So arrowhead here. So now you can better understand that their tails are joined. Okay, so let's go to the next part. Now this is how you draw the parallelogram. Both these lines, they are equal. Both these lines, they are equal. And so parallel to this line, I have to draw a line here. So one method is using the the compass. So I will open the compass 4.9 centimeter. I will put the compass needle here. I will take this point as center, and I will draw an arc here. Here you can see that arc is already drawn. Then I put the compass needle on this point, and I will 4.9 centimeter arc. I will draw arc here. Okay. I will take that point as the center of the arc. So now you can see these two arcs. Where these two arcs are joined, so that's the point, join it here and join this point here, automatically a parallelogram will be formed. You can see this. So this is the method by which I have drawn, by using a protector and compass and scale, I have made this parallelogram. Now the resultant, where these tails are joined, you join it with the opposite corner. That will be your resultant. So you can see this red line, that's the resultant. So with the help of the scale, measure the length of this line. When I measured this line, it was 9.2 centimeter. So this resultant is 9.2 centimeter long, and 1 centimeter means 10 kilonewtons. So 9.2 centimeter means 9.2 multiplied 10, that will be 92 kilonewton. 92 kilonewton. Hopefully you understand this. Okay, now let's check that was the A part. The B part is, he says, the engines of the ship are not operating and the water in the harbor is stationary. The ship is moving in a straight line in the direction of the total force exerted by the tugboats. It is traveling at a constant speed. Explain in terms of the forces acting why the ship is moving in a straight line at constant speed. You see why the ship is moving at a constant speed. You see the tugboats, they are providing, this force is making an angle. So one component of that force is in this direction towards the right. So the force which is towards the right, a component of this force which is towards the right, and that is equals to the friction of the water. So the resultant force will be 0. Plus the component of that force which is towards the top of the page here and towards the bottom of the page, they are equal and opposite to each other. So they are also balanced. So the net force acting on this ship is 0. The force to the right is, which is the force provided by the tugboats, is balanced by the friction of the water. And the force which is towards the top of the page, that is also provided by the tugboat, and force which is towards the bottom of the page, that is also provided by that tugboat, that lower tugboat. And they are also balanced. So the resultant force acting, or the net force acting on the ship, is 0. So that's why the ship is moving in a straight line with a constant speed. Let me show you my answer. I have also written this answer. Okay, so here we come. So forward force by the tugboats, and the backward force, friction of the water, are equal. Forces acting to the right are balanced by the forcing acting towards the left. So the net force on the ship is 0. That's why the ship is moving at a constant speed. Okay, so we are done with the question number 1. So let's have a look at the marking scheme. And on your screen, the marking scheme is showing up. You can pause the video and take your time with this marking scheme. And I always tell you that it's very important to compare your answers, compare my answers, compare your teacher's answers with the marking scheme. It's a must. So I hope that I have already checked my answers with the marking scheme. So pause this video, take your time, you can check it, okay? So let's move to the next question. That's question number 2. A force applied to a solid object may cause it to accelerate so that its velocity changes. State 2 other properties of the object which may change when a force is applied. So when a force is applied, its acceleration will change, its velocity will change. These two things I have already mentioned in the question. So you have to name any other 2 properties which can change by application of the force. So one can be the shape, the other can be the volume and the density. Okay, so the pressure can also be changed. So very easy. It's a very easy question. Okay, so the shape and the volume. Okay, now the next part. A spring has a mass of 0.012 kg. The gravitational field strength G is 10 Newton per kg. Calculate the weight of the spring. So the weight of the spring will be W equals to mg. That's the formula. So mass is given, the G value is given. You just put those values in that formula, and automatically you will get the answer. So W is equals to mg. The m is 0.012 kg, and the G value is 10 Newton per kg. Just multiply them, and you get 0.12 Newton. So that's the weight of that spring. Okay, so then we have the spring is suspended vertically and a load is attached to its lower end. The spring extends by 2.7 centimeter and does not pass the limit of proportionality. Figure 2.1 shows the spring and load attached to the lower end of a second identical spring. So this is the first spring, and this has been attached with the second spring. Okay, suggest one reason why the extension of the second spring differs from 2.7. So both these springs basically are identical. But when this load was only attached with this first spring, the extension in the first spring was 2.7 centimeter. But now this second spring is experiencing this load, plus it is also experiencing the weight of this spring, this first spring. So the extension produced in the second spring obviously will be more than 2.5 centimeter because it is experiencing the weight of this load plus the weight of this first spring. So that's why the extension in the spring number 2 will be more than 2.5 centimeters. It's a 1 mark question. Hopefully you understand the idea. Extension of the second spring will be more than 2.7 centimeter because the second spring has to bear the load and the weight of the first spring. Hopefully you understand this. Okay, so let's move to the next part. He says, explain what is meant by the limit of proportionality. Limit of proportionality is a point on the extension load graph beyond which the extension and the load, they are no more directly proportional to each other, beyond which the extension load graph is no more a straight line with a constant gradient, it becomes a curve. Let me show you my written definition. Okay, so here we go. So point on the extension load graph beyond which the extension is not directly proportional to load. Hopefully you understand. The load in the figure 2.1 is pulled down below its equilibrium position. State the form of energy stored in the stretch spring. So you see, when you pull a spring downward, the spring will stretch. The spring has a restoring force in it. So when you pull it downward, you have to work against that restoring force. So the work you do against that restoring force, that work is stored in the spring in the form of elastic potential energy. So here you have to only state the form of energy. You don't have to give this whole explanation. I'm just trying to explain to you. But in the answer, you only have to state. elastic potential energy. That's the answer. Then this says the load is released and it moves upwards and downwards. The distance traveled in each movement decreases until the load stops moving. Explain why the load stops moving. You see, when the spring is vibrating, the load is moving up and down. It has to overcome air friction. So when you overcome air friction, your energy converts into heat, which is absorbed, which is dissipated into the surrounding. So the heat energy, thermal energy, which went into the surrounding is a loss of energy. It cannot be recovered. So as the spring is vibrating, it's losing energy in the form of thermal energy to the surrounding. So ultimately what will happen? It will lose all its energy and it will stop vibrating. So let me show you my written answer. Elastic potential energy is stored in the stretch spring. That's the first part of question number 2C part. Question number 2C, second part, when the spring moves up and down, it has to overcome air friction. So its energy will be converted into heat, which is lost to the surroundings. Hopefully you understand. So that was the question number 2 and its C part. So the question number 2 is completed. So let's have a look at the marking scheme. So my dear students, the marking scheme for the question number 2 is showing up on your screen. I have already checked my answers with the marking scheme. You can pause the video and you can take your time and check my answers, your answer, your teacher's answers, written answers in a book. Compare them with the marking scheme. It's very important. I have already checked my answers, so I'm confident. Okay, so let's move to the next part. Okay. A solid rectangular concrete block is lying horizontally on flat ground with one of its largest sides in contact with the ground. Figure 3.1 shows the dimensions of the block. So the length is 0.44 meter, 0.21 meter. The height is 0.13 meter. So this face, the largest face is on the ground, is in contact with the ground. The weight of the block is 240 Newton. Calculate the pressure on the ground caused by the block. So here I can find the area of the block which is in contact with the ground, and the pressure will be weight divided by the contact area. Very simple. It's a 2-mark numerical. Okay, so here we go. So the contact area will be the length and the width of that face which is in contact with the ground, and that will be 0.44 meter multiply 0.21 meter. So the answer will be 0.0924 meters square. So that's the area. So pressure will be equals to force divided by, the force here is the weight of the block, that's 240 Newton, and the contact area with the ground is 0.0924 meters square. So just divide them, you get 2597.4 Newton per meter square. In the standard form, it will be 2.6643 Newton per meter square. Hopefully you understand. State why the total pressure on the ground underneath the block is larger than the value obtained in the A part. So we have calculated the pressure on the ground due to this block, and we have used only one factor, that's the weight, which is acting downward on this area. But in reality, there is also atmospheric pressure acting on this block, which is also acting downward, and it is causing force on this block. So we have ignored that force. So in reality, the pressure, actual pressure acting on the ground due to this block will be more than which we just calculated in the A part, because there is atmospheric pressure and it is also causing a downward force on the concrete block. So this is a 1-mark question. So let me show you my answer. Atmospheric pressure is also acting on the block. Okay, so the next part. The block is of uniform density. State the height of the center of the mass of the block above the ground. You see, this is height of the block, that's 0.13 meter. Center of the gravity to center of mass will be in the center. So its height will be half of this height. Okay, so 1-mark numerical. So height of the center of the mass will be 0.13 meter, which is the height of the block divided by 2. So it will be 0.065 meter. Okay. So that was the C part and C first part. Now we are on the C second part. The block is rotated about its lower left hand edge so that it comes to rest on one of its smallest sides. This is shown in the figure. So we have moved it like this and it is now standing like this. This is shown in the figure for 3.2. Explain why work is done as the block is rotated. You see, when you rotated it, a center of gravity was here, center of mass was here. Now it has gone here. So its center of mass has gone up, it has gone higher. So the gravitational potential energy of this block will increase. So that's why I can easily say, because when there is a change in the energy, the energy has increased, its gravitational potential energy has increased, so the work has been done. Or you can also say that because the block has moved in the direction of the force applied, that's why the work is also done. Okay, so let me show you. It's a center of mass rises, block gained gravitational potential energy. So that's why I'm saying that the work is done. So we are done with the question number 3. So let's, okay. So the marking scheme of the question number 3 of this paper is showing up on your screen. You can pause the video and take your time and read this marking scheme carefully. It is very important to always check the answers, compare them with the marking scheme. And I think that our answers are right. So let's move to the next question. A 75-watt filament lamp is in an office is accidentally left switched on for 63 hours when the office is closed. Calculate the electric energy that is supplied to this lamp in this time. Okay, so the power of the filament lamp is given and the time is given in hours. So I can calculate the electric energy used, and there are two ways to do this. One way is to calculate the electric energy in kilowatt hours, and for that you have to convert the power in kilowatts, and then you take the time in hours and you just multiply them, you get kilowatt hours. The other method is to find the energy in joules. For that, the power will be taken in watts and the time will be taken in seconds. So 63 hours, so each hour has 3600 seconds. So you multiply 63 with 3600 and you get the time in seconds. So let me show you. I have done this in both ways. So that's the first thing, and I converted the power 75 watt, I converted into kilowatts, so divided with 1000, so 0.075 kilowatts. The time is 63 hours. Energy is equals to power multiplied time, so 0.075 kilowatt multiplies 63 hours, so you get 4.725 kilowatt hour. The second method can be you calculate the energy in the joules. So the power will be taken in watts and time will be taken in seconds. So to take the time in seconds, you have to multiply the hours with 3600 to convert them in seconds. So 75 multiplied 63 multiplied 3600, you get 1.7 x power 7 joules. So this much energy is produced. Okay, it is used by the lamp. That was a 3 marks numerical. The efficiency of the lamp is 0.12, or you can say 12%. Calculate the energy released by the lamp in the form of light. Okay, so basically they are asking us to, the input energy we know already, 1.7 x power 7 joules, and the output energy will be, the useful output energy will be light. They want us to find out that, and they have told us that the efficiency of the lamp is 12%. You know the formula for the efficiency is equals to the useful output energy divided by the input energy multiply 100. Efficiency I already know is 12%, and useful output energy is question. Input energy to the filament lamp is 1.7 x power 7 joules into 100. So useful output energy will be equals to 12 multiply 1.7 x power 7 divided by 100, and that will be 2.04 x power 6 joules. That's the useful output energy, which is light. Okay. So that was a 1 mark numerical. Now they say the power station that generates the electricity supplied to the office uses oil as its fuel. State and explain whether oil is a renewable or a non-renewable source of energy. We have to state and we also have to explain. Okay, you see the oil, its resources. If you exhaust the oil from a well or underground oil or offshore oil, once you exhausted those resources, you will not be able to replenish them. You will not be able to reproduce them. So that's why the oil is a non-renewable energy source. So let me show you my answer, written answer for your reference. Okay, oil resources once exhausted cannot be replenished. So oil is non-renewable source of energy. The next question which they are asking is, discuss one environmental consequence of using oil as a source of energy. It's a 2 mark question. You see, when you burn oil, when you combust oil, when the combustion of the oil is taken place, carbon dioxide is produced. Carbon dioxide is a greenhouse gas. When it goes into the atmosphere, it increases the greenhouse effect. And due to the greenhouse effect, the global warming is on rise. Another, the damage of the carbon dioxide, it causes acid rain, and which changes the pH of the water. It can change, it damages the buildings. So let's have a look at my answer. I have written a very simple answer. Combustion of oil produces carbon dioxide, which increases greenhouse effect. This causes global warming. Okay, so we are done with the question number 4. Okay, so my dear students, on your screen, the marking scheme for the question number 4 is showing up. It is always very important whenever you solve a question, pause the video and have a look, take your time, read this marking scheme, compare your answers with the marking scheme. Check my answers, your teacher's answer, the answers you have in the red spot. Compare them always with the marking scheme if you want to master this paper. So hopefully you have checked the marking scheme. I have already checked my answers with the marking scheme. Okay. Now, question number 5. A process called nuclear fusion takes place in the sun. Discuss the process of nuclear fusion taking place in the sun. So you see, in the sun, it's a 3 mark question. What is the nuclear fusion? In the nuclear fusion, 2 or more than 2 smaller nuclei, they come close to each other. Nucleus actually repel each other, but the conditions are such that it's very high temperature there, it's very high pressure there, they are moving at a very high speed. So when they come close to each other, they overcome that repulsion of the positive and the positive, the nucleus which are repelling each other, that repulsion is overcome, and they fuse into each other and they make a larger nucleus. And when this happens, a small mass disappears. It converts into energy. So enormous amount of energy is produced. This is happening on sun. On the sun, the hydrogen atoms, the hydrogen nuclei, they come close to each other at very high speed, at very high temperature, at very high pressure. And those nuclei fuse into each other and they make the nucleus of helium, which is a larger nucleus. And during this, some mass disappears. It converts into energy, according to the Einstein's equation of energy and mass transfer. Interconversion into each other, E equals to mc square. So due to that, enormous amount of energy is produced. So let me show you my written answer. Okay, so Here we go. In nuclear fusion, smaller nuclei join to make a larger nucleus. On Sun, hydrogen nuclei come close to each other in the presence of very high temperature and pressure. They fuse into each other and make nucleus of helium. This produces enormous amount of energy. During this process, some mass converts into energy. That's why enormous amount of energy is produced. So this is nuclear fusion, which is taking place on the Sun and other stars. Hopefully you understand and you remember this idea. Okay, so on Earth, solar panels and solar cells are powered by the energy from the sun. Describe how this energy from the sun travels to Earth. You know that between the sun and the Earth, there is vacuum and there is no medium. So the energy from the sun is coming to the Earth in the form of infrared. Infrared radiation is a part of electromagnetic spectrum. Electromagnetic waves do not require medium to travel. So the energy from the sun is coming to the earth by the help of electromagnetic waves and infrared rays, and they do not require medium to travel. So that's why the energy will travel. Okay, so question number 5b part, energy from sun to earth travels in form of infrared radiation. Infrared are electromagnetic waves. They can travel without medium, so they can travel through the vacuum very easily. So that was the question number 5, and it's B part. So I think we are done with the question number 5. Okay, so let's have a look at the marking scheme. So my dear students, on your screen, the marking scheme for the question number 5 is showing up. Pause the video and have a look at this marking scheme. I have already checked my answers, and it's very important to always compare, check your answers with the marking scheme. Okay, so we are moving to the next part. Figure 6.1 shows a girl standing a few hundred meters in front of a large building. The girl uses a signal generator and a loudspeaker to send a short pulse of sound towards the building. The sound has a frequency of 3700 hertz. A short time later, the girl hears an echo. State what is meant by the term echo. Echo means when the sound waves go and they reflect from a rigid body and come back. That is, those sound waves which are reflected from the rigid body and come back to you, we call them echo. So it's a 1-mark definition. So let me show you my written answer. That's question number 6a part. Sound waves, when reflected from a rigid surface, are called echo. Okay. Now, the next question. The pitch of the echo is the same as that of the original sound, but the echo is not as loud. State what has happened to the amplitude of the sound wave, the frequency of the sound wave. You see, the pitch depends upon the frequency. So if the pitch is still the same, it means the frequency has not changed. And the loudness depends upon the amplitude of the sound wave. So if the loudness has decreased, it means that the amplitude of the sound wave has decreased. So question number 4, question number 6b part. Let me show you my written answer. Okay, so amplitude of the sound wave has decreased because the loudness has decreased. The frequency of the sound wave remains same because they're saying that the pitch has not changed. So that's the okay. The sound in air is 330 meter per second. Calculate the wavelength of the sound, and we already know the frequency of this sound, that 3700 hertz. So I know the frequency, I know the speed of this sound, and I want to find out the wavelength. You remember that famous wave equation, V equals to F lambda, and lambda is the wavelength. I can easily solve this paper. So F is 3700 hertz. The velocity is 330 meter per second. The lambda is question. So I will use V equals to F lambda. So lambda will be V by F. 330 divided by 3700, 0.0892 meter. Multiplied with 100, it will be 8.9 centimeter. Multiplied with the 10, so you will get 89 millimeter. You can write this, you can write this, you can write this as answer. So this is how you find the wavelength of the sound wave. You calculate the wavelength of the sound wave actually. So we are done with the question number 6. So my dear students, on your screen, the marking scheme for the question number 6 is showing up. You can pause the video and you can take your time and have a good look at this marking scheme. It is always very important to check your answers, your teacher's answers, with your mentor's answer, your online teacher's answers with the marking scheme. Okay, so let's move to the next question. The next question is question number 7. A 4.5 volt battery is connected in a circuit with an ammeter, a light dependent resistor, LDR, and a 1800 ohm fixed resistor. Figure 7.1 is in the circuit. So here you have a battery which is 4.5 volt. Here you have an ammeter which will tell you how much current is coming from the battery. Here you have 1800 ohm fixed resistor. The resistance is not changing. This is LDR. So its resistance depends upon the light. If there will be brightness, its resistance will be less. But when it will be dark, its resistance will be high. Remember one thing, one concept is very important because these two are connected parallel to each other. So on both of them, the potential drop will be same. So there is no other resistance connected here. So the whatever is the EMF, same voltage drop will be here on the whole circuit. On both of these. So this individually will have 4.5 volt voltage drop. This one also will have 4.5 voltage drop. So it's a very important concept because they are connected parallel to each other. So the voltage drop here and the voltage drop here, that will be same. And because there is no other resistor here, these are the two parallel resistors connected with the battery. So whatever is the EMF, same is the voltage drop here. What they same is the so the voltage drop here will be 4.5. Voltage drop here will be also 4.5. It's a very important concept. It will be used in the next part. The resistance of the LDR is 9,000 ohm. Calculate the total resistance of the circuit. The total resistance, these two are the only resistors here. So they are connected parallel to each other. I can find their equivalent resistance. That will be the resistance of the whole circuit. So 1 by R equivalent will be equals to 1 by R1 plus 1 by R2. It's a 2-mark numerical, and I know both the R1 and R2. So very easily I can find out the total resistance. So 1 by R equivalent is equals to 1 by R1 plus 1 by R2. So 1 by R equivalent will be equals to 1 by 1800 plus 1 by 9000. So in my calculator, I added them 1 divided by 1800 plus 1 divided by 9000 equals to, and the calculator gave me the answer in the fraction, that is 1 by R equivalent is equal to 1 by 1500. Cross multiply, so the R equivalent will be 1500 ohm. So the equivalent resistance of these two parallel resistors will be 1500 ohm. Hopefully you understand this numerical. Okay, so the next part is the reading on the ammeter. Once you know that the ammeter is telling you how much current is coming from the battery. So if you want to calculate the current coming from the battery, the formula is I from the battery is equals to EMF of the battery divided by the total resistance of the circuit. It's a 2-mark numerical. Let me show you. Okay, so the I from the battery is equals to EMF divided by the R equivalent. So it will be 4.5 divided by 1500. So the answer on your calculator you will get will be 3 expo minus 3 ampere. 10 expo minus 3 means milli, so 3 milliampere. So this much current will be shown on by the ammeter. Okay. Now, he says a very bright light is switched on and the light intensity on the LDR increases. State and explain what happens to the current in the LDR. You see, when the light will shine on the LDR, the resistance of the LDR will decrease. So when the resistance of the LDR will decrease, the resistance of this whole circuit will decrease. So the current coming from the battery will increase. So because here on this branch, the resistance is lower. So a more amount of current compared to the previous amount of current, the amount of current flowing through the LDR will increase because the resistance of the LDR has decreased, because the resistance of the whole circuit has decreased, because the current coming from the battery has increased. So the current flowing through the LDR will increase. Now, the current in the 1800 ohm resistor, you see 1800 ohm resistor, its resistance is fixed. The voltage drop on this is still 4.5. So if the voltage drop still here is 4.5, its resistance is still here 1800. So the current through this branch will be still the same. I is equals to V by R according to Ohm's law. Because voltage has not changed, voltage drop has not changed on this branch, the resistance of this branch has not changed. So the current through this branch will not change. It's a technical answer, question number 1. And the second part is very technical, you know. Let me show you my written answers. Okay. So in bright light, the resistance of the LDR will decrease. So the equivalent resistance of the whole circuit will also decrease. So the current from the battery will increase. So the current through the LDR will also increase. And in the B part, across 1800 ohm resistor, its resistance has not changed. The potential drop is still 4.5 volt. I told you the concept at the start. And whatever is the EMF of the battery is still the same. And same voltage drop will be on the LDR and same voltage drop will be on the fixed resistor because they are parallel to each other. That's the concept. So the current, which is I equals to V by R, if V is still the same, R is still the same, so it is still the same. So the current through the fixed resistor will still the same. Hopefully you understand. The second part was little technical. So we are done with the question number 7. So on your screen, my dear students, the marking scheme for the question number 7 is showing up. You can pause the video and take your time, read this very carefully, check how much marks are for each step. Compare your answer, your teacher's answers, my answers with the marking scheme always. Okay, so we are going to the next question. I have already checked my answers with this marking scheme. In the engine compartment of a car, the battery supplies a current of 120 ampere to the starter motor. The starter motor is switched on for 3.5 seconds. Calculate the charge that passes through the starter motor in this time. So the current is given, which is 120 ampere. The time is given, that's 3.5 seconds. I want to calculate the charge. You know, I is equals to Q divided by T. So Q will be equals to I multiply T. I means current, T means time, and the current should be in the amperes and the time should be in the seconds. So here is your first numerical. I is equals to 120 amperes, T is equals to 3.5 seconds. The charge is question. You know the famous formula, I is equals to Q by T, charge divided by time. So charge Q is equals to I multiply T. So 120 amperes multiply 3.5 seconds. So you get 420 coulomb. 420 coulomb. Hopefully you understand this numerical. It was a 2 marks numerical. He says a starter motor circuit is switched on and off using a relay. The relay is controlled using a second circuit. A switch in the second circuit is used by to drive to operate the relay and turn the starter motor on and off. Explain how the current in the second circuit controls the relay. Okay, so let me show you. So this is the basic structure of a relay. This is that second circuit. It has low voltage, low current. And this is that first circuit of the starter motor. It will have high voltage, high current in it. So what we do, you see when I close this switch in the circuit number 2, this solenoid will become an electromagnet. This is an iron armature pivoted here. So when this becomes an electromagnet, it will attract this vertical portion of the iron armature towards the left. And when this will move to the left, this horizontal portion of the iron armature will move upward. When this will move upward, it will lift this, it will rise this contact, and it will touch with this contact. So the path of the current in the circuit number 1 will be completed. So you see, by using the switch in the circuit number 2 and the use of relay, this is called relay, we are able to switch on and off circuit number 1. So let me show you. When switch in the circuit 2 is closed, the solenoid becomes electromagnet. This attracts the vertical part of the armature towards left. Horizontal part of the armature rises up, which lifts the lower contact of the circuit number 1, and the circuit 1 is completed. So because both those contacts touch each other, then the circuit is completed. So by using the lower voltage and smaller current in the circuit number 2, circuit number 1, which has high voltage and high current, can be switched on and off with the help of the relay. So this is how the relay works. Hopefully you understand. It's a very, very important description and the diagram. Okay. So we are done. So we are done with this video, with this session. And my dear students, my name is Ferhan Mazher. And today we have done October, November 2017 Physics 505422 paper. In this video, we have only done the section A of this paper, which was from question number 1 to question number 8. Section B of this paper we will do in another video. I will upload that section B. So if you think that this video is helping you, it has helped you understand the concepts of the physics, it's helping you to practice your past paper, and you think that this can also help your friends, your class fellows, your cousins, please share the link of this video onto your Facebook accounts, into your Instagram account, and onto your Twitters or other social media links which you have, because this will help me promote my channel, and that is a great appreciation. It's a big appreciation for me, and which is a fuel for me, and I can work. So it's a great blessing for me to be helpful to so many people online. So thank you very much, everybody. Have a good day, and God bless you all.